And this is kind of using the same thing as what we were doing last week with the function notation. So basically we get to choose inputs. That's going to be our x's. That's going to be our input. And we're going to take these different inputs, these different numbers listed here, and we're going to plug it into this function, into this equation. So I'm going to take these values for x and plug them in, substitute them in place of x. So I'm again looking at this equation, y equals the absolute value of x. So if x is -3, that means I'm going to plug in -3 for x. And so y would equal the absolute value of -3. What's the absolute value of -3? 3. 3. So that's going to go right there. And so my point, this ordered pair, is what I'm going to write in this third column, where I write x comma y. So that's going to be -3, comma 3. It's really ugly, 3. -3, comma 3. Okay, let's do the next one. Y equals the absolute value of -2. What does that equal? 2. So my ordered pair would be -2, 2. How about -1? Yeah, the absolute value of -1 is just 1. So my x comma y, my ordered pair would be -1, 1. Whoops, yeah. Okay, can you guys finish the rest of the table? I think you can. So finish up the rest. And then once we're done filling out the table, we're going to graph the function. So look at these different ordered pairs. We're going to put a point at each of those ordered pairs. So the first one is at -3, 3. -3 is my x-coordinate. 3 is my y-coordinate. So I go to the left 3 and then up 3. That's my first point. -2, 2. Go over to -2, up to 2. Okay. And then keep going. Fill out. Plot all of these points. Okay. So we'll go through and just connect the dots. And this is going to be our line, or our function. What is the shape of the function? Yeah, it's a V. Why does it connect it like that? Weird. Yeah. We don't need to. So let's talk about the slope. The slope of each part of the line. We can find the slope out right from the graph. Do we see how this side is going to have a different slope than this side? Yes? Yeah, because this side, the slope is negative. This side, the slope is positive. So let's figure out the rise over run for each side. So for the left side, over here, what's going to be my slope? Kind of. So we, yeah.
On what side?
This side.
Oh.
Except it's going to be down 1 over 1. Down 1 over 1. Down 1 over 1. So that would be, our slope on that side is going to be -1. And what do you think it would be on the other side? +1. Exactly. Okay. Where is the vertex? What is a vertex? You guys ever heard of that before? A vertex? Kinda, yeah. Yeah, it says 0, 0. It says 0, 0. And all a vertex is just that like point where the two, kind of like what you said, where the two lines meet. It's going to be that point there. Okay, and so the domain is going to be all our possible x values. All the possible x values. So, can I put any number in for x? Yeah, I can. I can put in -552. I could put in 10,305. I could put 7. I could put -8. I could put any number I wanted to. So, and I can tell that because these two lines go out in either direction forever and ever and ever. So on this side, it's going to go all the way out to -infinity, and on this side, it'll go out to +infinity. So my domain is from -infinity to +infinity. And then my range is all the possible y values, all the possible values vertically. Does this graph, is it going to touch every single value from -infinity to +infinity? It is? Does it go down here at all? No. What? How could it go down there?
Different problems.
So, talking about this function, could we ever get a point down here? Why not?
Just
It's a good guess.
Crashed. I'm sorry.
What?
They already crashed at that 0.
Yeah, they crashed at the 0, but also, can the absolute value of a number ever be negative? No. Even if I say the absolute value of -9, what is it?
9.
Absolute value of -100 is?
109.
No, but 100. So an absolute value is never going to be negative. Will never be negative. So it's never going to show up down here. Okay, so our range is now from 0 to infinity. Okay, so it's all these numbers above 0. All the numbers above 0 is our range. That's our possible y value. Okay. Now we're going to go to the other page. And we're going to talk about, like what Dominic was saying, different types of functions. So pull out that other paper I gave you.
Absolute value.
Absolute value functions. Okay. All right.
It's already
Huh? What?
pretty much the middle of February.
I know. It's past the middle of February. There's only like 86 days left of school. Well, 86 days until the end of school. Less than 86 days. For seniors. So for you.
If you
I was
do.
gonna say.
Not quite. Okay. So this is the graph we just plotted. We just drew out, right? This is what we call the parent function. It's the parent function because this is the one that's like, that where all the other ones come from.
So the parents malfunction?
Did you say parents
Oh,
malfunction?
parent malfunction. I think not parents.
No, parent function. So it's going to be the like first and foremost function, and then there's going to be different variations.
I'm tired.
It's okay. So this up here, y equals a times x minus h, absolute value, plus k. This is going to be like our standard form of absolute value functions. Okay? And the a, the h, and the k are all going to be replaced with numbers. X and y stay the same. The number negative h and the number k tell us where our vertex is, where the two lines collide. Okay? So we're going to practice first finding the vertex from different equations. Okay. So again, this is our function, or this is our equation, our standard form. So I'm going to negative h and k tell us where the vertex is. Negative h and k. So in this equation here, y equals the absolute value of x plus 2 minus 3. Where is h showing up? 2. Okay. And then where's k? Where's k? 3. Yeah, thank you. 3. Yes. So we need to pay close attention to negatives here. This is saying our vertex is at negative h. So that would mean that our vertex is at negative 2, negative 3. This ordered pair, that's a point on the graph that is going to be the vertex.
That's it.
That's it.
I'll assume the next one's negative 1, 0.
Yeah, not negative 1,
Positive.
positive 1. So because our vertex is at negative h, that means we take a look at whatever number's here, and we just flip it to the opposite sign. So since this is negative in here, when we write the point, it's going to be positive. So it's going to be 1. And then, yeah, there's like a invisible plus 0 right there. 0 is our k. How about number 3? What's going to be our h?
1. Negative 4.
What's the invisible number inside of here with the x?
0.
Plus 0. Huh?
How?
So if you add 1 to a number, does it change that number? 2 plus 1, does it change to something? Yeah, what does it change to?
3.
3. But if I add 0 to a number, does it change it?
No.
No, 2 plus 0 is still 2. So
1
if
plus
I,
1 is 0.
what?
So
I That's all I needed there.
So 1 times v it's just 1. So is that just 0?
But we're looking at the number being added to x, not multiplied by it. You see? So if there's no number being added to x, then we can assume that it's just 0.
Oh,
Okay? So 0 is going to be our h. And then what would k be?
4.
4. Okay. So that's our first step when we want to graph an absolute value function, is we want to find the vertex. And then we create a table just like we did before, graph the points, connect the dots, and that's it. Okay, so let's go through. We'll do these two together. Well, we'll do them all together, and then I have other practice ones for you to do. So what's my vertex going to be for this one?
0.
0 and
-2.
-2. Does everyone see where that comes from?
What?
Where these two numbers came from? You gave them to me, so I'm assuming you know.
Yeah. So taking the size problems. Times by 0.
Yeah, and then the -2 came from right there. So we're going to put the vertex in the middle row right here. So 0, -2. And then I want you to choose two numbers to the left of the vertex and two numbers to the right of the vertex. So two numbers less than 0, two numbers greater than 0. So someone give me one number less than 0.
2, 3,
-3. Let's do that. Okay, and someone else give me another number less than 0. Do in between 0 and -3. -2. Okay, and then let's mirror that. We'll do 2, +2, and +3.
and for the other side.
And then for the other side, what we do is what we were doing last week, where we take our input value and plug it in to our equation. So I take these different values for x, and I substitute them in for x in my equation. So for -3, that would be y equals the absolute value of -3 minus 2. What's the absolute value of -3?
0.
3.
Oh, absolutely.
So 3 minus 2 equals
1.
1. How about -2? Y equals the absolute value of -2 minus 2. What's 2 minus 2 equals 0. Okay, now let's do the other 2. So if I plug in 2, y equals the absolute value of 2 minus 2. What's the absolute value of 2?
2.
Not -2, just 2. So 2 minus 2 is 0. What do you think 3 is going to be?
1.
Yeah. So let's go ahead and graph these points. So the first one's at -3, 1. -2, 0, 0, -2, 2, 0, and 3, 1. Should just be a V again. If it's not a V, then we took a wrong turn somewhere. Okay, now how about this one? Let's find our vertex.
-1x plus 21.
What's going to be our vertex? Where's our H? Did you hear that? Whoa, spooky.
What?
The second you said 0, someone in that room said 0 too. That's weird. That doesn't happen very often.
Copying me?
Never happened to me. I've never seen it happen. 0.
Scared. What if that person's following?
What if you're following them?
And I'm turning around.
Okay, back to this. Y equals A times X minus H plus K plus K. Where is my H in this example? The 2 is going to be positive 2 or negative 2 when I write my vertex.
Negative.
Negative 2. It's going to be the opposite of what it is in here. Negative 2. And then where's my K?
Well, yeah.
0, because it's not written. So I can just imagine it's there. Negative 2, 0.
Wrong.
Okay. And then, so let's put this in here. Negative 2, 0. So we're going to choose two numbers smaller than negative 2.
1. Negative 1.
Is that smaller than negative 2?
Yeah. 0.
-4.
Negative 4. And one more over here. Negative 6. Okay, and then what do you want to use up here? What should we use up here? 1 and 4. Those are the first two I heard. Okay, and then we plug these in. Plug them in. So y equals negative absolute value of negative 6 plus 2. Okay, so when we're doing this, we need to first solve what's inside the absolute value. It's kind of like parentheses. What's negative 6 plus 2?
Oh, 4. Negative 4.
Negative 4. So y equals negative absolute value of negative 4. So what is the absolute value of negative 4?
4.
4. So y equals negative 4.
Oh no. Butter.
Do we see how we got there? Let's do another one and see if, because of this guy right there.
You punk, he's hiding.
Okay, let's do the next one. Y equals negative absolute value negative 4 plus 2. Y equals negative absolute value of, what's negative 4 plus 2? Negative 2. So y equals negative, and what's the absolute value of negative 2? So y equals negative 2.
Is that guy right there?
Yeah. Okay. Now let's do 1.
Why is it so
Y equals negative absolute value 1 plus 2. y equals negative, what's 1 plus 2?
3,
What's the absolute value of 3?
3,
So y equals negative 3. Yeah? Okay, last one. Y equals negative times the absolute value of 4 plus 2. Yeah, so y equals negative absolute value of 6.
it's negative.
So it's just y equals negative 6.
And name enough lines for 6.
1, 2, 3, 4, 5. So to count by twos. 2, 4, 6. So this first one is at negative 6, negative 4. So I'm going to go over to the left, negative 2, negative 4, negative 6. And then down, negative 2, negative 4. Next one, negative 4, negative 2. So negative 2, 0.
Upside down B.
1, negative 3, 2, 4, 2, 4, 6. Yeah,
Red dot name on the line.
what do you mean? Yeah, that dot. It's okay. So what did that little hiding negative sign do?
Made it go down.
Yeah, I made it upside down. Turned it upside down.
Well, almost right.
Wow.
It's Wednesday.
Today
I
went by
know.
really fast.
Because we've been missing Monday, Tuesday.
Yeah. Okay, let's flip over to the back.
There's a bad thing.
There's a back. Okay, let's do this one together and then you'll do number 6 on your own and then we'll be done. Okay, so what's a vertex? A vertex, 3 and 2, 3, 2. Okay, so that's going to be, you'll have to write in your table here. This is going to be the middle row in my table. So it's going to be 3, 2. Now let's pick two numbers smaller than 3. Give me one. A number smaller than 3. 1. And another one. Ray, a number smaller than 3. That isn't 1.
2.
I was asking Ray. 2? Okay, can you give me a number smaller than 2?
Number smaller than 2. 1.
Smaller than 1?
0.
0. That's better. A number greater than 3?
4.
And one more? 6. Okay, then we take those values and plug them in up here. So 0, I'm going to plug that in, y equals absolute value 0 minus 3 plus 2. So y equals, what's 0 minus 3? 0 minus 3.
3. Well, negative.
Negative 3. Yeah, but it's an absolute value, right? So it's going to be the absolute value of negative 3, which is 3 plus 2. So what does y equal? 5. Yeah. Now with 1. Y equals 1 minus 3 plus 2. Y equals the absolute value. What's 1 minus 3? Negative 2 plus 2. Y equals, what's the absolute value of negative 2? 2. So what's y equal?
4.
4. Good. Okay, y equals absolute value 4 minus 3 plus 2. So y equals, what's 4 minus 3?
1.
1. What's the absolute value of 1? 1. 1 plus 2 is 3. And then y equals absolute value 6 minus 3 plus 2.
3.
Yeah, y equals 3 plus 2. 5. And then we graph. Okay. So you should have a graph for that. And then, just because we're running out of time, just give me the vertex. Give me the vertex for this. Vertex. Find the vertex. That's your check your understanding today. What is the vertex? What was our first step? We did it like how many different times? We've done it 5 times together. Give it a try. Vertex. Remember, it's going to be y equals a times h minus, whoops. Okay, so turn in what you have, please. Those 3 pages.
That was funny. You just picked the first. I just turned.
Have a good day.
He's already close to the room.